All right, here's our nomenclature review. I'm going to bring it all together. This is covalent, ionics, everything. All right, your first step is you got to determine whether or not it's covalent or ionic because they have different rules. And so we've got to look at that first and foremost. And so easiest way to do that is look at the beginning of the formula. If you're looking at a formula, look at the beginning of it, or even a name. If it starts with a metal or ammonium, then it has to be ionic, because covalents are always nonmetal and nonmetal. Okay, so that's the first thing you can do to look for it. The second big clue is that covalents are always going to have prefixes. Even if it's just one of the second element, it's going to have a mono in there. Remember, the only exception to that is dichromate, as that polyatomic ion. But for general rule, this will help you distinguish. So is the first element a metal or ammonium? It's ionic. If it has prefixes, it's covalent. And that's just a really quick thing to distinguish between the two. All right, so the first thing we got to practice is doing just that. Identifying whether or not something is covalent or ionic by looking at the name or the formula. So carbon dioxide. That's a nonmetal, which means it's covalent, and I also have a prefix. Calcium hydroxide starts with a metal, no prefixes, so it's ionic. Iron 2, the fact that I've got a big Roman numeral there tells me it's ionic. Okay. Sulfur trioxide, nonmetal and a prefix, covalent. Silver nitrate is what this is. This is a metal, so it's ionic. Ammonium, ionic. Nitrogen, nonmetal, covalent. Copper is a metal, ionic. Okay, so you're just looking at that first element, with the exception of this being a whole polyatomic ion. And you're looking at that first element, and if it's a metal, it's ionic. If it's not, it's covalent. All right, I generally tend, for me, the prefixes part is the backup. For me, I'm primarily just looking at the first thing. Non-metal, covalent. Metal, ionic. Metal, ionic. Non-metals, covalent. And that's how I'm doing it, just looking at that first element. Okay. So just quickie review. If it's covalent, we just need to use prefixes. For the name, just use the quantity of each, determine the prefixes. For formulas, use the prefixes. Covalent's easy. Just make it match. All right? But you got to identify it correctly first. So if it's covalent, just use the prefixes to solve everything. All right. If it's ionic, things get a little bit more tricky. But real quick, just reviewing covalent first. These are all covalents, so just use the prefixes. Dinitrogen pentaoxide, tricarbon octahydride, carbon monoxide, phosphorus trihydride, dicarbon hexabromide, C2Br6, and then dihydrogen monoxide, otherwise known as water, H2O. Okay. All right, ionic. Ionic's just more complicated, just hands down. Whenever you figure out the ionic, you really need to split it apart. You need to look at the positive ion, then you need to look at the negative ion. So if it's a formula, just break it up. Fe2 is over here, O3 is over here, and then worry about naming this part, and then worry about naming this part. Same thing with a name. Once you have the name, just split it into its two parts. Worry about the formula for this, and then worry about the formula for this. I think if you divide and conquer like this, it keeps things a lot less confusing, and it is a really helpful way of doing it. Okay. Because positive ions can be one of three things: ammonium, a regular metal, or a transition metal. All right, so for example, ammonium sulfide, or magnesium sulfate, or lead 2 chloride. And so you've got to look at that positive ion, figure out what it is, how it behaves, and if it needs a Roman numeral. And if it's not, not need a Roman numeral, then you just write the name and you're done. Positive ions are the easy ones. Okay, for the negative ion, you once again have three options. It can be a nonmetal, which just means it ends in IDE. It can be one of the polyatomic ions from our pattern, and we just got to look at the pattern to figure out oxygen and the charge and the name. So iron 3 carbonite. So carbon's outside the box, normally has 3. Ite is 1 less, So CO2 with a 2- charge. And then you can also have your one you're supposed to memorize, lithium cyanide. So all this gets put into a big flow chart. You have this in your workbook, or a version of this in your workbook. I don't think it doesn't look exactly like this one, but it's still the same idea. Is that you need to think through how to do this. And so it's slow and steady. Until you get really, really comfortable with nomenclature, you need to do this. So first step, identify if it's ionic or covalent. If it's covalent, you do your little happy dance, and it's quick and easy, use the prefixes. If it's ionic, you go, okay, let's work on this. So then split it up. Look at the positive ion, look at the negative ion. Do what you need to do with the positive ion. Do what you need to do with the negative ion. Okay? And then just think through it and then put it all together. Okay? So in the workbook is practice, because once we get out of this chapter, we're not going to separate ionics and covalents anymore. They're going to all be present at the same time. And so we need to be able to do with those. Okay? Acids have their own nomenclature system, but I'm not going to focus on that right now. I'm going to save that for when we get to acids and bases later. So if you run into an acid, I will give you its name and its formula until we get to the end. And when we get to acids and bases, we'll look at the actual process of naming acids. I just want you to focus on this main part right now. And so make sure you know how to do this, because once again, going forward, there is no distinction between covalent and ionic. I'm just going to give you a name and expect you to write the formula, or give you the formula and expect you to know the name. And so you've got to work on getting this down. This is the, if knowing the elements is the alphabet, these are the words. And we're about to get into reactions where we're going to start doing the sentences of chemistry. So make sure you understand how to do the words so that we can start making sentences together. And I will see you in the reactions unit.